Hi, I'm Josh Selander. I'm field service for Las Vegas, and I'd like to welcome you to Introduction to Show Control. The first thing that I want to talk about is what the expectation is and what you'll actually hopefully learn about show control by the end of this class. So the first thing is knowing the different types of show control that actually exist. Next, we're going to talk about what actually fits your application best. And the last is going to be different ways that we can implement that type of show control in the EOS product line. So first of all, let's talk about what show control actually is. I think of show control in a very simple way. It's an autonomous technology that links varying components together. There's three different ways, though, that we can do this, or three different types of components that we may connect together. That may be lighting, sound, or projection, and sometimes automation may be included with that. So what are the three different types of show control that we actually use in this class today? Will be timecode. Now, timecode can include both SMPTE timecode or MIDI timecode. It could be triggers. These could be internal triggers, or these could be external triggers. Or it could be a time of day event. So it could be what we refer to in EOS as real-time clock. So first of all, let's talk about what MIDI timecode actually is and how we may use it. MIDI timecode is used to keep two devices in sync with each other using timecode. Basically, simplified, MIDI timecode is exactly like SMPTE timecode, but it's mutated for transmission over a MIDI cable. It has a lower bandwidth capacity than that of SMPTE, but the main difference between MIDI and SMPTE is MIDI is a digital signal, whereas SMPTE is something that just runs analog. So talking about SMPTE, where it originally came from was the film industry. So it was originally used to sync film with audio. It's normally transmitted over a 3-pin XLR cable, and it can be transmitted with any type of output device. The different types of triggers that we're going to talk about today, we're going to talk about serial triggers. These types of triggers are typically from maybe a paradigm processor, our architectural controller, to an EOS, or maybe it was UDP, that was an iPad to an EOS console. We're also going to talk about MIDI, and this is MIDI show control, which is actually a trigger that we may use to connect a laptop to control a console, or maybe we'll use analog inputs. Analog inputs are a way for us to actually send a trigger into the console, but maybe not from a device that's actually has the technology to do that data transmission. So the first thing with time of day that we'll talk about is time of day. What is it actually used for here? So in the actual EOS show control display, there's a time of day section that you can program in. And within this time of day section, you can actually have different events that have different triggers, and each one of these triggers can happen at any given part of the day. So any of these triggers, when they're fired, they can be fired via a astronomical clock, meaning 30 minutes before sunrise or 30 minutes before sunset, or they can actually happen at a specific time on a specific day within the console. And the different things that we can actually trigger here are cues or subs or macros. So a great example of this is if you think that you're going to be running a little late from lunch today, maybe you want to put in your time event to actually trigger your work lights to turn on back at 1 o'clock before you actually make it back into the theater. Sub-protocols of MIDI. Today we're going to talk about MIDI timecode. Like I said before, that's just a different version of SMPTE. MIDI show control, which are pre-established MIDI commands. These are sysx commands that you can send from one console to the next. And then we'll talk about MIDI notes. MIDI notes are mostly used with musical instruments, but some of the consoles actually will send or receive these commands as well. So let's talk about why show control. To integrate products that don't natively communicate together. That's really the main reason. Or to sync audio and lighting, or audio and video, or audio and lighting and automation, the different departments of the theater. It could also be to have a seamlessly executed show or performance, especially shows that are the same type of show every night. So let's talk about one of those. Maybe that's a show at a theme park. Maybe that show has some type of automation with lighting and audio and fire. Or it could be a dance recital that you need time code for. It could also be as simple as a trigger. It could be a wall switch. Or it could be when you want that blackout to happen when the actor closes the door. The blackout could actually be triggered by the actor closing the door. Different types of MSC triggers could be older moving light console talking to an older conventional console. Time of day could be triggered in a mall. Maybe you wanted the mall to turn on at 7 o'clock in the morning and turn off at 10 o'clock at night. So the first thing that we'll talk about here is actually components that are involved with sending time code from a device to another device. So there's different elements of that. Obviously, we need a console. So we'll be using an ION or an EOS for this example. We'll need a show control gateway, and that show control gateway can do both MIDI and SMPTE protocols. We'll also be using a USB to MIDI interface, and this is something that you can pick up from the internet. You don't need to spend anything expensive. They're fairly cheap devices. And then we'll also use a program just to see that we're sending that time code. So within the console, the actual screen that we have in the console is within setup. And what we actually have here are 3 main buttons that we're talking about, specifically with time code. So we have SMPTE time code, which is enabling it to receive, MIDI time code receive, and then how many frames that we want to see for it to resync. Within the actual gateway configuration editor, this is our application, by the way, to configure what that show control gateway does. We have similar settings for the gateway, but these are what we would refer to as the source ID numbers. And each one of these ports on the back of the gateway actually have a source ID attached to them. So when we talk about this in the actual console, when we look at that show control event list that we saw before from timed events, what we have is we have 2 main parts to this. The top of the screen will actually show us our events that are used in the show control display. The bottom of the screen will be our actual event list. In the event list, we would have to specify what the actual type is of the show control, what that source is. Now that source is that number that we had specified before in Gateway Configuration Editor. The source number is equivalent to saying, hey, what port did I plug this MIDI in, or what port did I plug this SMPTE into? We then have internal or external. Internal will basically say, I want to have a backup for my show control. So if my internal or if my external signal of show control is lost, should the console automatically turn the internal time code on and continue on with the show? You have your first time and last time. These are the times that you basically want to see as the first or last. And then you actually have how many frames per second. And EOS supports 24, 25, or 30 frames per second. And then at the very end of this list, you have the actual status display for the actual show control list. So moving on, looking at the actual events, the options that we have for the event are obviously the number and the label. Once you have your actual show control list created, what you would want to do is associate your cue list with the actual show control list. And this is a simple option done in the cue list display. Once this is done, you can actually begin creating your events for your time code. Now there are 3 different ways that we can do this. The first way is by using the learn function that exists in the console. And what you're able to do is actually enable a learn function and have the console learn every time that you fire a cue or a sub or a macro. It could also be inputted manually from live by manually typing in the cue to be executed via the time code with a specific time, and the same command can be done from blind as well. So when we talk about different triggers that we can use in the desk, we have a couple of different options for that. So the first object that we would need to have triggers is that same gateway that we had before, that same show control gateway. With that gateway, we have similar settings like we had before, except instead of using SMPTE this time, we'll be using MIDI this time. We have additional console settings that we can change. Within these console settings, we have MIDI show control receive and transmit. We'd want to make sure that these are both enabled if we were using both. We also have the receive channel. MIDI actually functions on 16 channels, 0 through 15. You would want to make sure that both channels of MIDI receive and transmit are equivalent to what your device is using that you are trying to either control or have controlled. The ACN MIDI transmit ID and receive ID are equivalent to those numbers that are from the gateway configuration editor. The MIDI string MIDI transmit is whether or not you're going to send MIDI raw, which is basically MIDI note. And then you have MIDI cue list. This is what actual cue list, if you wanted to specify, would the console be always sending out. So if you only wanted it to send list 1, you could specify only send list 1. So talking a little bit about the I/O gateway, we have different options for the I/O gateway. And the I/O gateway is one way that we can use external contacts, we could use external analog inputs, we could use RS-232 serial to actually control a console or another device. So talking first about the actual internal functions of that gateway, we have either contacts in or analog in. And this is just a setup screen built into Gateway Configuration Editor to actually set that up. We also have the same settings in the console for either enabling analog inputs or enabling relay outputs. So talking about analog triggers first, one of the great uses of an analog trigger that we use is having a source 4 as a follow spot. And sometimes you want that operator to be able to manually control the light, but you still want the console to have control of that light as well. So what we're able to do is use a 0 to 10 volt fader and actually have the operator fade the light up and down, but it actually is an analog input into the desk. That analog input into the desk is actually controlling an inhibitive submaster that turns that light on or off via the cue. So if the console needs to black out the light, it can still black out the light. We have the same type of screen that we used before for timecode that we do for analog triggers. So our analog trigger that we have is very, very simple in how we have to set it up. All we have are the source number, which remember, that's basically your gateway or the port number, and whether or not you want it to be enabled or not enabled. Relay outputs are another option that exists in the console. A great example of a relay output is a dowser for a projector. Maybe you need a way to dowse a projector, but you don't have the budget to actually rent a dowser for your projector, or a grayscale dowser or a grayscale scroller. So one of the ingenious ways of using relay outputs is having the console send an output to a CD-ROM drive. The CD-ROM drive has a piece of metal in the actual tray. So when the console sends it a trigger, the trigger actually opens the tray and douses the projector. When you send it a trigger again, the console opens the tray, or closes the tray in that case, and the projector is visible on the stage. This is actually done by sending a relay command from a queue. It's just a matter of selecting the queue. There's a soft key called execute in the desk. You'd press that, and then you would actually be able to execute a relay and specify what relay number that actually was. Another option that we have for triggers are serial triggers via the gateway. Now, this isn't something that we use too often, but it does exist. It's via RS-232. You can do it via from a computer, or maybe from a paradigm processor to an EOS console to that I/O gateway, obviously. But this is something that does exist. Within Serial, though, there are some obviously additional setup options that you have. Same rules as before, you're always going to have an enable for both the receive and the transmit. You're going to have your group ID numbers, and you're going to have your receive group ID, your receive ID numbers and your transmit ID numbers. These all have to match depending on what device it is that you're controlling. The last option that you'll see is something called string transmit IP address. And this is actually if you are going to send a UDP network signal to another device. One of the options that we have for this, for different types of commands that we could send, are go1, macro. We could send a fire command, so Q1, 2, that would be QList1, Q2, or subdown 5. One of the options, though, that we give you now is to do this all via an iPad or maybe via UDP. So there's different apps that are available on the market that allow you to actually control a device using UDP. UDP is simply just network serial. So what you're able to do is, if you needed multiple buttons on your iPad and maybe you didn't have a client dongle to control your console from a laptop, but you still needed the ability to actually control from a wireless location, you could actually send a UDP signal to control your show. With time clock and real timed events, the first thing that we want to make sure is set correctly is the time. So the time and date, and specifically the time zone, all need to be set correctly. If you were going to actually use astronomical time clock, meaning sunset, sunrise, then you would want to also make sure that your latitude and longitude were also set correctly. You have additional setup options for real-time clock as well in that show control display. Within that show control display, it's very similar to how we set everything else up before. We would want to specify what time we wanted the event to happen, where we wanted that event to take place, meaning what day, and what that event actually does. Different things that we can do with that time clock, like I said before, is turning lights on at a specific time, but more importantly, maybe turning lights off at a specific time. Different tools that we'll use a lot in testing. MIDI aux is a really great test program that we use for testing different MIDI functions. It's a Windows program that we'll use a lot in R&D and test. It's really great on site because it also works with that simple USB to MIDI adapter that I spoke of earlier. QLab is an amazing program used in shows for actually controlling those different commands. It can be very simple from just sending a MIDI time code or a MIDI show control, but you can be very specific and you can have different groups within the program that would send different types of commands, meaning maybe it started your time clock, but it also started the video, which also started music, and all of that was synced together in one simple application. Other useful things that I've had for UDP, obviously we can use Paradigm. Paradigm does accept and send UDP. Also, Mote is a program for iPhone, iPad devices. It's a simple program used mainly at home usage for controlling televisions. Command Fusion is another program that exists for home automation, but it's a great use for controlling the consoles or controlling whether that be Paradigm or any other device that supports UDP. So really what we're talking about here is the first thing with show control, how do we actually decide on it? So the first question to ask yourself is, what devices are you actually trying to integrate? The next question that we want to ask is, are you trying to actually sync time between those devices, meaning sync time between lighting and audio? And then what need is there for the console to be controlled by anyone besides that operator? Is there a need? Does the operator need to be there? So in conclusion with that, show control is used to integrate different types of technology together, whether it be lighting, sound, projection, pyro, or automation. Time code, triggers, and time of day are all what we would consider types of different show control. And the tools you choose for the show depends specifically on what devices you're actually trying to integrate and how they should all work together. Because in the end, everyone's needs are going to be different. If you have any questions, always feel free to contact technical support, and thank you.